the basic electricity, if we want to know what the electricity means, what the current is, what the voltage is, we have to really deep dive into what is an atom, because that is a basic building block of a matter. Okay, so the word atom is a basic building block of a matter. What does that mean is everything which exists in this cosmos, which you can see, it is what? It is matter. And the basic building block of that matter is atom. It means also that every material or everything which we see is made up of the compositions of all of these atoms fused together. So one atom over one atom over one atom, it makes a basic structure of anything. A human body, it is also made up of atoms. So this atom is having a lot of energy in it, right? And that's what we want to harness the energy out of this atom so that we can utilize in form of electricity, right? Just like an atom bomb. You guys have seen this atom bomb, right? Or maybe you guys seen the atom bomb? Yeah. Okay, but you may have, I don't know, may have seen a prototype of that. But yeah, there are wars, people are using the atoms like atom bomb, hydrogen bomb. So so the very less amount of this atom can make a disaster, right? It has so much of energy, right? So how we can utilize this atom and really convert that to electricity? How we can utilize the energy of the atom? So before we go there, we need to understand the structure of the atom, okay, so that we understand what the electricity means. Okay, now what I'm going to show here is one example, and with that example we are going to learn the structure of the atom as well. One example, one is a mother earth. Okay, so this side earth and this side it's atom. So we'll see how this both comes together, right? The same, the structure. So if you remember how the earth looks like, you will never forget the atomic structure. Now, help me out. If I need to represent earth or draw an earth picture, what I should draw first? Circle. Great. So we are going to draw a circle, right? So this is earth. Okay. Similarly, in the same way, to draw an atom, we are going to draw a circle. So instead of earth, this circle or the portion of this at the center, it is known as nucleus. It is known as nucleus. So instead of earth, and now basically this portion is earth core, right, or earth crust. Similarly, you have the crust of the atom or the core of the atom, which is known as nucleus. In earth core, you have lot of items, like you have minerals, you have diamonds, you can say iron, and you will have lava, hot lava, all those things, lot of things are there, right? And core is a very dense form, it's a very solid, right, in the earth. Similarly, in nucleus, you have lots and lots of proton. And there are lots and lots of neutron. Okay? And these are bound together, like these are, merged together inside, right? And they are like a solid core, right? That's a solid core base. So this proton have positive charge. The charge of the proton is a positive, okay? And the charge of neutron is zero charge, zero. But they gets combined together to become a nucleus, just like a earth crust. Now tell me, what is there outside the earth center or outside the earth crust? We are living here, right? We have a house here, we have trees here, there are a few birds flying by, there are some fruits we eat, right? So what is there? What is surrounding the earth? Exactly, atmosphere, right? So we have atmosphere. Now these atmospheres are in different layers also, right? As you go up, the density of air decreases, there will be different kind of gases, right, in the atmosphere. So we can say that Earth has lots and lots of atmosphere, so it has a different layers of atmosphere, right? I can draw it like a circle, okay? Different layer of atmosphere. And as you go out of the atmosphere of the Earth, this is space. So like a GPS system, we put our GPS satellites here in the Earth's atmosphere, and it can really, can look at the specific area. But if you want something out of the space, you send another space shuttle out there, okay, to read about Moon, Mars, whatsoever it is, okay. So this, just like a Earth atmosphere, you have an atmosphere around the nucleus, okay. This is the word nucleus, which is, so this atmosphere is also having like layers, different layers, okay. Instead of gases in the atmosphere of the Earth, for the atom there are something called electrons. There are lot of electrons, lots and lots of electrons surrounding this nucleus, okay. You have electron at the outer side also. Any doubt? Now what this electron do is, just like the Earth atmosphere, the atmosphere is also spinning with the Earth, right? It is going spinning, right? Similarly, the electrons are spinning around the nucleus in haphazard manner, like it don't have a direction, it goes like an electron cloud, right? It is going here and there. In order to break the Earth crust, right, it is going to need tremendous amount of energy, right? Because you have to drill it. As you go down, the more and more the pressure will increase, right? Have you seen the movie Core? The Core. So they developed a machine, and they said that Earth has stopped rotating. So now everything is, falling apart, because it's all about magnetism and all. So they discovered a machine which will dig to the Earth, and they will go to the core and put some nuclear bomb out there so that the lava can start. So in order to go to the Earth, as you reach inside, it will be more and more pressure. But if you go towards outside, it will be less pressure, right? Similarly, in this case, what is happening is the electron cloud is surrounding the nucleus. In order to harness the energy from the nucleus, it is going to be very tough, right? Instead of that, if we can harness the energy out of this electron, which is at the outermost shell, sitting outermost, it will quite easy compared to this. Now, these electrons are different for different elements, okay. Different elements, these electrons are different. There will be different number of protons and neutrons. Now tell me, if I ask you that if we have 5 people over here, okay, what is the maximum possible group you can make out of 5 people? 2. You will make 2 groups, that will be 4 people, so 1 person will be left over. What I can do is I can take that person, I can fit him anywhere I want. It will quite easy to fit in, right? Rather than breaking the group and making again. If somebody is standing alone, I can make another group. It will be easy. Similarly, we really need to see how many electrons are there in the outermost shell. These things are known as shell. Like an eggshell, these things are known as shell. Actually, it is known as valence shell, but no need to go there, but it is known as shell. And remember this, that the outermost, how many electrons are sitting at the outermost, that we are going to use for electricity. So like I said, if 1 person is there, I can really utilize it very easily and put a group just like that. In this case, what is happening, these electrons are also bounded to this atom with some energy. So we have to find some electrons which are loosely bound, which we can really take it from this, right? We are going to learn next is how to utilize this electron. So there is a word in electricity called current. So what is current? Current is nothing but it's a flow of electrons. It's a flow of electrons that is known as current. Okay. So it may be in one direction only, it may be back and forth, doesn't matter, but it has to be a flow of electrons. It's not one electron, it's electrons, right? So this is, I'm talking about just one atom, which is a basic building block. If I take a copper bar, just like this copper bar, right? This copper bar has trillions and trillions of atoms in it, which is making this a solid copper bar, okay? And this copper is an element, right? So there is something called in the periodic table, well, I'm not going there much, but all this kind of elements are being classified in a periodic table with, for example, hydrogen is classified as, I think hydrogen is 1, okay, so like 1, 2, 3, 4 like that, you know, but all these gases, elements, metals, everything are classified in a periodic table. What does that say is, like for example, hydrogen is a gas, okay, its atomic structure is different, it has a nucleus and one electron, right? Similarly, the copper, its number is, I believe it is 29 in the periodic table, okay. No need to stress on that. What it says is, all this metal and elements which exist physically in nature is having a different atomic structure. One of the best thing with the copper is, the copper has one electron at the outside of the shell. That if this is a nucleus of the copper, which has proton and neutron, right? There are 29 protons in it. Outside the copper, we have one electron sitting here. So in the aluminum, you have a nucleus and proton and neutron, and outside the outermost shell in aluminum have 3 electrons. This is for the aluminum. For copper, you have 1 electron. For aluminum, you have 3 electrons. Right now, in this case, in the outermost, you have to take away 3 electrons from aluminum. Okay, so the energy requirement for taking out 3 electrons from aluminum is going to be high compared to the copper, because copper has only 1. That is the reason copper is one of the best conductor which we use for any operation, especially for grounding or anything. The best conductor of electricity, or you know, having a very good conductor of electricity, is silver. Silver is one of the best, is the bestest available, okay? But since it is more costlier, we are not going to use silver everywhere. If you go down there, you will see it comes with a silver plating, okay? Because silver is much more, conductive. It's more good for electricity, right? We cannot use silver. Just assume if we are using all silver in transformer, it will be $1 billion transformers then, okay? So we cannot do that. So copper is the best for cost purpose, as well as it is very good from the conductivity point of view. It is the one which can be formed as a very, like a hard conductor as well if we need. That is also good. So copper is altogether is a very good, metal which we can use. Okay. Now tell me, if I use this copper wire and I touch this, am I going to get any shock? Why? Because, and this has these electrons, right? This has lot of electrons. So it has lot of electrons here, right? Because it's trillions of atoms building this, billions and trillions of atoms building this whole copper, right? So it will have billions and trillions of electrons in it, right? But I'm not getting a shock, because once you see the copper bar, now I'm drawing this, okay? So it will have billions and millions of, it's maybe trillions and trillions of nucleus like this, and all of it has electrons, one electron at the outermost shell. But what it is doing right now in this case is this is moving haphazardly from here, here, it is moving here, exchanging within itself, but it is haphazardly moving like in any other direction, random direction, which is no use to me. Okay, because in order to have a current, the definition of current is what? Exactly, it's a flow of electrons, right? So we need to have the flow of electron in one direction. One direction is any direction, either this side, either forward, either backward, but all the electrons should come together and it flow in one direction. Then only we can really see the impact of the electricity. So for example, we have an outlet of 120 volts, right? If I take my finger and put it on one of the circuit, what is going to happen?
I'm going to laugh.
Well, I get a lot of shock in my life, right? Not even 120, like 220 volts shock. Yeah. Back in India, we have 220 volts, not 110. It's much more safer here. Okay. So what happens is if I put my finger in, the whole electrons is going to flow through my body to earth, right? Because it has to get the circuit complete. But there is no voltage available at that point of time. Let's say the circuit is off, I can touch it still, right? It will have electrons and everything in the wire itself, but it is not moving. Since it is not moving, I'm not going to get shock. Similarly, in this case, what happens, if your electrons are not like it is staying within that, it is not going to pass through my body right now. That's what I'm touching, because it is haphazardly moving. But once it will start moving in one direction, in a particular direction, in a one direction, then if I touch it, I will feel the shock, I will feel the electricity, can feel the current. So that is the current, is flow of electron in a certain direction. Okay, that's a flow of electron. Now we have a copper conductor, and we know that in this copper conductor there are lots of copper nucleus and copper atoms of this, and we have lots and lots of electrons. Now if I put a bulb across it, okay, this is the representation of the bulb, okay, this I'm drawing, this is a bulb, B-U-L-B, okay, how do you say it? Bulb? How do you say it? Pronounce it for me, guys.
Bulb.
Bulb. Okay. Bulb. Okay. Sorry for my accent. Okay. Okay. It's a bulb. Okay. Now, tell me this: if this is a circuit, so this is the wire, copper. Okay. Don't think that this is copper bar. Just think that I have magnified this, and this is the copper wire. This is the wire. This is the wire. It has lots and lots of electrons, and with a magnifying glass, I'm looking at it. Okay. So in this case, do you see the bulb will glow or not? Will it glow? So I have connected this bulb with two wires, like wire from here and here and here and here.
Yeah.
Is it will glow or not? If I take two wires here, connect this copper bar to a bulb, is it going to glow? I can put two wires across the bulb. Is it going to glow? No. Right? You can do that experiment at home. Okay. So if there is a bulb and it's just a holder and two wires are coming out, it is not going to glow unless you are going to put in a outlet or to a source. Correct? You see this is open circuit. People miss to see that. It is open circuit. Circuit is not complete.
Yeah, that's why I said
Even if I make this and say circuit is complete, still it is not going to glow. Right? Because electrons are not moving. It is staying the way they are. So what they need some kind of external force to move the electron in one direction, correct? So I need to have something out there which will actually push the electron in one direction, and that one is known as voltage. So the voltage is nothing but voltage is like pressure. It is just like a pressure. It pushes the electron in a certain direction. So remember this, current is a flow of electrons, but in this case the electron is moving haphazardly, it's not flowing in one direction, so we need to have some kind of external source to push this electron, and that source is known as the voltage source. And what is voltage? Voltage is just like a pressure, it is pushing the electrons. Means the more voltage you keep increasing, the more electrons it will keep pushing. The more electron it will keep pushing, the more current will flow. That's why you see, if you see the electrical devices, or if you see the wires, right, they comes with some rating encrypted on it, right, that says it is suitable for 5 amps, 10 amps, or this is suitable for this much amps. What does that mean is, if you keep increasing the voltage, the current will increase so high, or the electron will actually started flowing so much that it will eventually burn that wire. Now the current, the current, which is the flow of electron, this is represented by the letter capital I. We say current as a capital I. Okay. The unit of a current means, for example, people usually say how much pound it would be. Correct? For example, if I want to say how much it is weighing, I will say how much pound it would be. So actually pound is the unit of weight. Similarly, if I say how much current is flowing, how do I know? I cannot say that 5 is flowing or 25 is flowing or 50 flowing. There has to be some unit, right? So that's why we say how much amps is flowing, ampere, okay? So the unit of current is ampere, A-M-P-E-R-E, ampere. People generally says it's amps, okay, A-M-P-S. And the unit is like pounds, we are writing LB as a symbol for the pound. Similarly, for the ampere, we are writing as capital A, not small a, okay, it's capital A. Units are in capital pretty much. Now the device with which we actually measure the current is known as ammeter. Ammeter, 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 whatever you want to call it, okay. So unit is, symbol is capital I, measurement is ampere, and we use ammeter for measuring the current. For voltage, the symbol is V, capital V, V as in voltage, okay. The unit of voltage is volts, V-O-L-T-S, and the symbol we use is capital V. We say it's voltage means V, okay. So 110 volts, how do you say it? 110 V, volts. Then the meter which we use to measure the voltage is voltmeter. Voltage meter means voltmeter, okay. V-O-L-T, voltmeter. So current is a flow of electrons, voltage is like pressure which pushes the electron in one direction. So once this voltage will push this electron, the electron will flow through this bulb, and then it will have the bulb lighten up or glow it. So this voltage, where we can find this voltage from? This voltage we can use a battery, right? Battery is the source of voltage. So the symbol of the battery basically looks like this. Bigger one is a positive, smaller one is a negative, and just like this. This is a symbol of a battery, okay? So once I have a battery, it will actually push the electrons to go through that bulb. So once you have one battery, it will glow the bulb. Once you have two batteries, the bulb will much brighter. If you have 3, 4, 5, maybe 6 times the bulb will go fuse. So what is happening? You are increasing the voltage, more and more electrons are flowing through the bulb, and the more electrons will flow, the more energy this bulb is getting to glow, right? But at certain time, a time will come where you will keep increasing the voltage and it is not going to withstand the electrons. It is going to burst out. That happens, okay? And once it bursts out, it can even catch a fire, it can heat up, all these things will happen, okay? Resistance. What does a resistance mean? What do you mean by resist? To resist, to block something, right? Not allow something to happen, right? So everything in this cosmos wants to be stable, okay? Very stable. Nobody wants to move, nothing. Everything wants to be stable. So once there is a change coming, or if something has to change, everything starts resisting it, right? Just like a human nature is, anything you are comfortable in, somebody comes and asks you to make some change, you will resist first. Your mind will resist first, or your subconscious mind will resist first. It happens. So there is some property of a material or a thing which resists a change is known as resistance. But in terms of electricity, how we see it, resistance, it is a property of a material, okay, to resist the flow of current. So every time we are not going to say flow of electrons, flow of this and that, nucleus and all those. It's in simple terminology, we are going to say the property of a material to resist the flow of current. Because when voltage is pushing the electrons in one direction, what is happening is the copper wire has a lot of atoms in it, but once the voltage is pushing this electrons, it means it is now taking this copper out of its comfort zone, because now the electrons are moving in one direction. So what is going to happen? This is going to provide a resistance to the current. It is going to say, hey, I am not allowing you to enter through me, right? But because of the voltage which is pushing the electrons so hard, it cannot 100% resist. It will have the electrons flow through it, right? This is a very important factor in electricity, which is resistance, to resist the flow of current. Now, in order to utilize the electricity, what you basically need is, you need a very basic circuit. And that basic circuit is, you need to have a power source, first of all, which is voltage. You need to have something which can carry the current, or which can really have the current flow through it, are the wires. These are the wires. And you really need something to utilize. Why you want a current and voltage? You want to do something, right? You want to run a machine, you want to run the fans, you want to run the lights, right? So you need something called load, electrical load, which is this, in this case, in this circuit you see a bulb, right? You can replace the bulb and you can put a fan, ceiling fan, you know, we have the fan in our house, I hope everybody does, or some kind of standing fan, something. You are putting it here, which is a load, and that's what you want to run. So we should have a source of electricity, which is a voltage. We should have something which can carry the electricity with it, which is a wires, and then we should have a load which we are going to utilize. These are the three things a basic electrical circuit needs. Now there is something called Ohm's law. Okay. So the name of the scientist is George Simon Ohms. He born in 1789 and he died in 1854. So in 18th century he actually gave a law for this. Law means there's a mathematical law, a universal law. See, everything has to be, some or other way, it has to be stable. Okay? Remember that. Everything in this whole universe has to be stable. Okay? Otherwise, it is not going to sustain. For example, when we have an atom bomb, why we have a bomb, why we have once the bomb blow off, why we have so much of energy coming out? Because when it breaks the atom, it is trying to make another atom. That's how it seeks the nearby, gases and nearby this and during that process, it relieves that much of energy. But ultimately, when the bomb blasts and gives away all the energy, there is going to be everything going to be stable after that for some time, right? Because now from unstable portion, it has become stable now, right? But it is going to take time. Similarly, in mathematics or in electricity, I would say there are some equations. The equations has to balance each other, right? When we talk about the mathematical equation, it means your right hand side of the equations should balance your left hand side. If it is not balanced, it's not going to work. Sometimes mathematicians, when the equations are not balanced, they say proportional, okay? Like it is proportional to this, where there is no equation, or you can put some constant value to make an equation. But anyway, so the Ohm's law says that if you have a circuit, a normal circuit which has a voltage source represented by V, you have a current flowing through the wire which is I, and you have any kind of load which is providing a resistance R. So if I draw this circuit, it will look like this. So I will have a voltage source, I will have a current flowing through this, and this zigzag is a representation of resistance, okay? So this is capital R. So this is my general circuit, normal electrical circuit. So what happens in this case is, Ohm's law says that the voltage is nothing but it is the current times resistance, or it is resistance times current. You can flip it, right? Correct? So generally, Ohm's don't say this, he wrote it like this. Voltage is I times R. So this voltage is actually supplying the current, and that current is going to the resistance. So voltage is I times R, current times resistance, right? So if you know this, and if I ask you find what is current, what will be the formula for current? It will be voltage divided by R. You're taking this R, putting it down here. If you have one side addition, it becomes subtraction. If you have one side multiplication, it becomes a division, like that, or division becomes multiplication, right? Simple mathematics. Copper is the material which we are using for electricity. I told you we are not using silver because it is very costly, right? We can build the transformer with copper, we can build the transformer with aluminum as well, okay? So why we are not using aluminum in this case is, aluminum has some limitations. If you see a smaller, very smaller transformers, people use aluminum, okay, because they don't have to carry much of a current. As aluminum is not a very good conductor compared to the copper, but it is still a very good conductor, okay. Aluminum is cheaper though, it is cheaper, so sometimes the overhead lines, what you see is the overhead lines, the transmission lines, right? So these conductors are known as ACSR conductors. ACSR conductor means A stands for aluminum. So this A means aluminum, C stands for conductor, and S stands for steel, and R stands for reinforced. So aluminum is not that tough. One tower is here, another tower is say 50 feet away. The aluminum is flexible, it will become sag. If there is an ice deposition at the top, it will sag. So what we do is, we use a steel inside and wrap the aluminum over it. But you are not going to see that steel. Once you see the wire, you see there is a aluminum wire going over. Copper is a very, very good conductor of electricity. This is kind of next to silver. Okay. Now, the second thing is the melting point of copper is very high. So it says melting point of copper is 1084 degrees Celsius, or it is 1983 degree Fahrenheit. Melting point of aluminum, you can note down if you want. For aluminum it is 660 degrees Celsius or 1221 Fahrenheit. So you can see the melting point of both are pretty good. Okay. But in the transformer you cannot design the temperature inside the transformer during the short circuit to go more than 250 degrees Celsius for the copper. Copper has a very high melting point. Why we need this? Because exactly, because the electricity generates heat and that heat can melt. Okay, but in a transformer, this is very important to see. In a transformer, what happens is, this transformer, it's a static device though. Okay, we are going to see it in our other lectures. So in this transformer, if I keep somewhere, that we have external bushings, right? It is going to this ACSR conductor. Now it is going thousands of miles, giving light to society and all. It passes through a lot of forest. It will pass through a lot of different area, right? It may have some trees. There may be a thunderstorm. There's something can happen, right? Maybe tree fall down. There is a storm. What happens is, if one of the line drops or any line drops, right? It is as good as a short circuit. So if your transformer can withstand, for example, I'm giving an example. If your transformer can withstand or is designed to withstand, say 500 ampere, during the short circuit, it may see, I'm not going to go really deep into the design, but just for your sake of knowledge, it is going to see about 5000 amps of current. So your transformer is designed for 500 amps, but at the time of short circuit, it may be seeing, or it may have 5000 amps current go through the wires of the transformer for 0.5 seconds. Why 0.5 seconds? Because this is the maximum operating time of a circuit breaker. Okay, so this much. So what is going to happen? The current is going to produce tremendous amount of heat inside the coil of the transformer, and if the temperature goes more than 250 degrees Celsius for the copper, it will start losing its elasticity, because you don't want copper to become brittle. It has some elasticity. It will start losing its elasticity. That is the reason we limit the temperature to less than 250 degrees Celsius when there is a short circuit happens. That all is a kind of design. But for you to take from this class is, you just understand that copper is a very good conductor of electricity. Next to silver, we use aluminum. Their melting points are higher. Okay, that's why we use copper. This is 99.9% pure copper we use. Now, there are two kinds of circuits in electricity. Okay, one is known as series circuit. Another one is known as parallel circuit. Series circuit and parallel circuit. So it's all about circuit. Remember that you have a source, you have a wire to carry, and then you have a load. Okay, simple. So if I draw a series circuit, it means when I say series or parallel, it all depends upon how your load is. Is your load in series with the circuit or in parallel with the circuit? Simple. Okay. For example, in terms of load, let's assume I have number one. I have a bulb number one, which has a resistance. Bulb will have a resistance. Any load will have a resistance, right? So bulb will have, let's say the resistance of the bulb is, okay, I did not cover one portion. Okay, sorry. Remember this. For resistance, what was the letter for resistance? So R is for resistance, right? Now the unit of resistance is ohms, and this is represented just like this symbol, ohm. This is a symbol of ohm. Just like current, 1 amps, 2 amps, 3 amps, 4 amps. Voltage, 1 volt, 2 volt, 3 volt, 4 volt. Okay? Like resistance, 1 ohm, 2 ohm, 3 ohm, 4 ohm. So let's say bulb number 1 is having 1 ohm. That is its resistance. There is another bulb, is bulb number 2 is having 1 ohm again. Now I have another bulb which is bulb number 3, which is 5 ohms. Okay? Now I have 3. Now I will have a voltage source. This is a battery, right? Plus and minus. For example, let's say this is 5 volt battery, right? Because let's do some maths as well. Okay, 5 volt battery. Now I have connected this wire directly to bulb number 1. This is bulb number 1, so I am saying it B1. Okay, bulb number 1. This bulb number 1 has a resistance of 1 ohm. I have connected another bulb which is bulb number 2. This is B2. It is also having a resistance of 1 ohm. I have connected another bulb which is bulb number 3. This is B3. And this is a resistance of 5 ohms. Now you tell me, if I connect it like this, is it going to be in series or parallel? How do you know is it series or parallel? Is once the current will flow through this is the current which is flowing, right? If the circuit is complete, your current will flow. Now watch this current. If the current is not splitting up, it means it's a series circuit. Okay, so once this current is flowing, the current flows through this bulb, it goes through this bulb, the same current, right? Current is flowing in this direction. See, it's going up, it's going across this bulb, it's coming down, going here, going up, across, going up, and then it is coming down. So the current which leaves here has to enter, same, that is the concept, that is the law. The current which leaves here has to enter this side. Okay, so the current is in one direction, one current is going through it. It means, you see, this current is here, the same current is here, the same current is here. It means all of these are connected in a series circuit. Use the equation V equals to IR. Okay, if I know the voltage is 5 volts, I know all of these resistance, right? The bulb 1 has a resistance of 1 ohm, bulb 2 has a resistance of 1 ohm, bulb 3 has a resistance of 5 ohm. Then what would be my current? Can you solve it and tell me? 0.71 is the right answer. Everybody gets that or no? So what is happening is, since the current is flowing in one direction, in order to utilize the equation, what was the equation? V is equals to I times R, correct? We know the voltage is 5 volts, correct? We know the voltage is 5 volts. That means I can write this equation as a 5 volt means 5 equals, I don't know the current, but I know the resistance. But what is this resistance going to be for this circuit? Now this resistance is not going to be just 1 ohm. This resistance is not going to be just 1 ohm of this, or this resistance is not going to be just 5 ohm. This is going to be, it's going to be 7. It's going to be, because for this circuit, everything is together applying this resistance, correct? Yeah. So in series circuit, your resistance all gets added up. So the total resistance of this is going to be 1 plus 1 plus 5 is 7 ohms. Got it? So the value of this resistance is 7. So now you can solve current, the I is equals to 5 divided by 7, which is 0.71 something, right?
Yeah,
0.71. So
0.71.
0.7, that's okay, 0.71 amps, okay? You have to write amps. Now, what happens to the parallel circuit? Let's see it. So we are going to say, use the same amount of bulbs, okay? We are going to use the same thing. So what we are going to do is, so we have a voltage source. This is plus and minus, this is the voltage source, right? For example, let's take this again. Let's say this is 5 volts. And now I have a wire. What I'm going to do is, I'm going to take this bulb, bulb number 1. I will have another bulb which is like this. Bulb number 2. I will have another bulb like this. Let's say this is bulb 1, this is bulb 2, and this is bulb 3. To make it easy. If the current is I, capital I here, what is the current going to be here? So it's the current, because this is still in series, right?
Yes.
But as soon as this current reaches this node, this point, now it can go in 2 directions. So now the current can split up like this. Now it is no more the same current. It is going to be different current, which I don't know yet. Okay. When the current splits up, we say this is a parallel circuit. So in parallel circuit, the current splits up. So now what happens in this case is, since the current is splitting up, so I don't know how much current it is going to be, I need to find out. So what I do is I name it, okay? The name of the current, I can say that this is small I1, this is small I2. I just name it, just like randomly. But since it's a current, so I am still using a letter I, right? Now this time small. So small I1 and I2. This is 1 and 2 are the designations. It's not a numeric value, okay? It's I1 and I2. It is flowing through this. Now you see, what is the bulb 1? The resistance of bulb 1 is 1 ohm. The resistance of bulb 2 is 1 ohm. The resistance of bulb 3 is 5 ohms. Now who can tell me what is this current? Okay, who can tell me? Tell your values. This is 5 ohms. This is 5 ohms, this is 1 ohm, this is 1 ohm. Bulb 1, bulb 2, bulb 3. So okay, let's solve this. Okay, this is little tricky. Okay. So remember this, that this is the simplest form, right? If you can break down your circuit to this, it will become simple to calculate. Okay. So for the parallel, whenever 2 branches are parallel, whenever 2 things are parallel, 2 resistance are parallel, if there is a 2 resistance which are parallel to each other, right? Let's say this is R1, this is R2. Okay, I can represent this as like this as well. Getting me? If I have 2 resistance in parallel, instead of showing like this, I can do like this, but now the value of the resistance will change. So the formula for this is R1 times R2 divided by R1 plus R2. Okay. Note down that formula. Well, I'm not going to derive that formula because it becomes 1 upon R equals to 1 upon R1 plus 1 upon R2, then do the mathematics. I'm not going there. I'm just showing you this R. So the effective resistance of the parallel circuit, of the parallel 2 circuit, is going to be R is equals to R1 R2, R1 times R2 divided by R1 plus R2. Okay. So what I can do is, in order to solve this equation or solve this, how I am going to do is, if I could actually merge this two circuit together to see like this, it will become easier, right? So what I can do is I can draw the same thing again. I can make it like a 5 volts, it's plus and minus. I will have a bulb here which is a B1, 1 ohm. Now instead of two branches like this, see the nodes, these two are common like this, right? These two are common, correct? So it means what I can do is, instead of these in the parallel, I can make to show like this. I can actually make to show like this. If I can do this and find the resistance of this, it is as good as a series circuit. It will be easier to find the current.
Yeah.
Correct?
Yeah.
It will be easier to find the current, correct? If instead of this I have this, it will be easier. So from there to here, I really need to see what is my resistance value going to be. From there to here. So for this resistance, I know if I have two branches like this, you see the branch is like this, correct? So if I need to really find, so these are the two nodes, if I really need to find the resistance across this, which is 1 ohm here and 5 ohm here, so let's say this is R1 and this is R2. So the formula is R1 times R2 divided by R1 plus R2. It means it will become 1 ohm R1 times 5, 1 times 5 divided by 1 plus 5. Correct?
It's 0.83.
How much it is coming?
0.83.
So it is coming 5 by 6 is equals to 0.83. 833.
Yeah.
Right? So it means
So
the value of R is actually 0.833 ohms. So I am going to write it here, 0.833 ohms. Now your circuit is simplified. Now you see? Now what is the resistance across this whole thing is going to be 1 plus 0.833. I am again merging it to one element. I will merge this because now the current is in series, right? So the whole resistance across this is going to be 1.833. Now I know the voltage. The voltage is 5 volts equals, I don't know the current. I have to find the current. I will current times what is the total resistance of this circuit is 1.833 ohms. So the current is 5 divided by 1.833, right, is equals to 2.72 amps. Okay. So let's say the voltage source is a battery source is 10 volts. Okay. Now you have a resistance. Okay. Now I instead of bulb I'm drawing a resistance value. Okay. This is how the resistance looks like. So this resistance is 1 ohm. There is another resistance which is 1 ohm. Tell me what is the current. Okay, let's see. Let's solve it. So first of all, the requirement is from this circuit, we have to make a small circuit. And that circuit should look like this.
that's 0.5.
And I don't know the R. Correct? So I'm merging these two circuits together and converting to this. So I have to find the value of R. What is the value of R?
0.5.
How do we get it? So when I say 1 ohm, it means, let's name it. This is R1, this is R2. Formula is R1 times R2 divided by R1 plus R2. It means 1 times 1 divided by 1 plus 1. Correct? 1 times 1 divided by 1 plus 1, which is 1 by 2, which is 0.5 ohms. So it means if I merge these two circuits together, it will be now equivalent or equal to 0.5 ohm. Now you do this. V is equals to I times R.
That's 20.
V is 10, current, and R is 0.5. The current is 10 divided by 0.5 is how much?
20.
20 amps. What will happen if I have another resistance in this circuit which is also 1 ohm? Now who can tell me the answer? The current. You have to merge the circuit to smaller ones. You have to keep merging it until you get the one circuit. Okay, let's solve it. Are you getting it? Now see, if you have to keep merging it, you have to do multiple calculations, not one calculation. You have to do multiple calculations. So you have to keep solving it
You gotta go from right to left.
till you get only single circuit in hand.
So,
But remember that equation is valid for two parallel circuit only. That equation R1 R2 divided by R1 plus R2 is valid only for two parallel circuit, like two circuits in parallel.
yeah.
Okay,
Yeah, so
but right now you have three circuits.
Oh.
You have to do two, make it one, and whatever it is, again it will become two, make it one. So now, first of all, instead of this, my ultimate goal is to reach to a level where I can do this. You know, I can do this. This is my ultimate goal, to find the current. So I have to find the resistance. What I will do, I know I have the formula which is R1 times R2 divided by R1 plus R2. This is the formula for effective resistance for two circuits in parallel. Whenever I have this. But here I can see I have three circuits in parallel. So what I will do is, first of all, I'll try to break these two circuits in one circuit. Like this. So earlier my circuit was 1 ohm here and 1 ohm here, right? So what I can do, I can use this formula, and when I will do this, I will see this is 1 times 1 divided by 1 plus 1, which is 1 by 2, which is 0.5 ohms. So now in this two circuit, I have taken that off. I can make this circuit from here to like this and say this is actually 0.5 ohms. Now again I have two circuits in parallel. So I will use the same formula, but now this time I have 1 ohm here and this side I have 0.5 ohms. So it will become 1 times 0.5 divided by 1 plus 0.5. It will be 0.5 divided by 1.5. It is 0.3, or how much it is? 333?
Yeah.
So now it means I can replace this whole circuit with 0.33 ohms. It means I can take all the circuit off from here and I can have a resistance now with a value of 0.333 ohms. Correct? Now what is your current? Your current is equals to voltage divided by resistance, which is 10 divided by 0.333, which is 30.03 amps.